the focus on the benefits the public might derive from the education of its citizens, but argue that those benefits will only occur if there is excellence, if there is high quality in teaching and learning, and went on to indicate where we could make greater advances in teaching and learning in higher education. The second of the two lectures indicated that the promotion of democracy depends on the kind of interactions that occur across segments. So even where there is polarization, and especially where there's polarization, the kind of interaction is very significant for people learning to live together. And went on to suggest then that's what can happen, or should happen, in university settings. Now tonight we're going to turn to the advancement of public well-being, again, fundamental interest for this course. Turn to the development of public well-being through the development of knowledge, or another way for putting it is through research, since research is about the creation, the forging of knowledge. Now here in Wisconsin, there's been a strong tradition centered on attention to questions that come from the problems that the populace faces. So when one is asking about the research kinds of questions, quite commonly those questions have come about because of particular issues that we're facing the public. The history of agriculture on the campus is filled with examples of changes prompted by research at the university. The dairy industry owes its beginnings very much, well, that is the growth of the dairy industry, owes that growth to partnerships between farmers who were facing declines in the wheat industry. That was the problem in the state. The wheat industry was going downhill, and the question was, what else might substitute? So groups of farmers came to the very small group of agriculturalists who were here at the time and said, well, how can we work on this? You can find more about this from last year's lecture. And let me remind you that these are all videotaped, and so you can turn to last year's lecture that was given, as it's called at the website, by the cheese folks. Because the cheese folks highlighted developments between the people, the farmers, and the agriculturalists on the campus, and the way that led to the growth of the cheese industry. But agriculture is not the only sector in which connections have been made between public problems and the university. One of the other areas of profound concern has been a set of issues centered on fresh water. And in fact, the university has become known, very well known internationally over time, for its research on freshwater systems. But I wanted to point out that the history of limnology, the topic for tonight, that history counters a view that teaching and learning is in fact incompatible with research. No, the close connection is what stands out in the examples from this university and things that we will learn about tonight as we look at limnology and the university. And one of the people important to that history is E.A. Burge. And you, of course, see names around the campus. But Burge, who was a faculty member, dean, and president. But what I want to point out about him is that he was favorably recalled by his students for his character, ideology, teaching methodology, and love of learning. One of the things that I do want to point to is from Layla Bascom, who was the daughter of John Bascom, and she took courses with Burge, and she described him as patient and understanding with any student who misunderstood or fumbled a bit. He gave them opportunities to get past the fumbling and was known for being very direct. But I point this out because it does help illustrate connections between the pursuit of knowledge through research and the development of the capacities in students to use that knowledge and to themselves continue to create knowledge. Now, our speaker tonight has drawn attention in the material that he's proposed that you take a look at, has drawn attention to the history of teaching, learning, and research in limnology. But he's superbly prepared to address the present and the future, given his own distinctive career. So Professor Vander Zanden is not here to tell us just about the history of Burge and others. He's going to capture for us the present, the future, the excitement that adheres in all the activities undertaken with reference to limnology. Professor Vander Zanden is professor of integrative biology and director of the Center for Limnology. He studies a variety of subjects: invasive species, water quality, climate change, and that's just a part of the list. He maintains as well an active research or an active outreach program. And along with his research and outreach, and keep in mind this is important, all of it's important of course, but let me draw your attention to the fact that he teaches what is possibly the world's largest limnology course. So we see that we have with us tonight someone who helps draw together a number of the facets important for the Wisconsin idea, but important for thinking constantly about links of education, of learning, of teaching, research, and the public. So it's no wonder that he was asked quite recently, just last week, ASSI, to address an audience on the topic, the Wisconsin idea in action. Professor Vander Zanden.
All right, well, thank you, Dr. Merritt, for that fantastic introduction. And I feel like if you've heard this now, you probably know what limnology is because Dr. Merritt referred to freshwater systems. So often for a talk like this, I have to lay out the basics and explain to people what limnology is. But I think we're all on the same page there. It's a pleasure to be able to give this talk. I had a really fun time putting together this material and sort of sifting through the history of limnology and trying to draw some of these connections to the Wisconsin idea. I'm relatively new in the director role, so for me it was a pleasure just to be able to think about the discipline that I'm in and the historical roots here at UW-Madison. And I think it is really important to tie together the teaching, the learning, and the research components. And I hopefully my discussion of limnology will be, for you, a case study of how these things, these different elements of the mission of an institution like UW-Madison tie together in a way where there's societal benefit. So a quick outline. I'm going to talk about water and Wisconsin in particular, and I like to kick off talks with just a little bit of Limnology 101, why water is important. I'll talk then about the history of limnology, and there's so much to talk about here. I had a hard time keeping this talk short, so excuse me if I go long. And then I'll talk about the Center for Limnology today and make some of the links to the Wisconsin idea. So when we look at the planet Earth from space, the planet is often referred to as the water planet. And it's so blue, there's so much water on the planet. 71% of the surface is covered by liquid water. But if you take all of that water on the surface of the planet and you condense it down, it creates a ball that big. So it's actually not that much water. We have a thin film of surface lining 71%, thin surface of water lining 71% of the globe. So all the water is that little marble right there. The fresh liquid water on the planet is that water right there. And the fresh liquid surface water, you probably can't even see it. It is a tiny little dot that might be the size of Atlanta or smaller. And it is a remarkably small volume of water when we look at it in this broader context. So water is a truly precious resource. Liquid fresh water at the surface that's available to us is not as abundant as we like to think of it. And the other notable thing about this is that the vast majority of the Earth's fresh liquid surface water is held in a handful of large lakes around the world. Lake Baikal, the African rift lakes like Lake Tanganyika, and 21% of that water is in the Laurentian Great Lakes, which again is quite remarkable. So we are sitting right next to an incredibly valuable resource, this massive body of fresh water. The reason why we have that water sitting in the configuration that we have is because of glaciers. About 14,000 years ago, glaciers rumbled across North America. North America looked like this. And as they retreated, they devastated the land and left a lot of terrain and bumps and folds. And in the creases and debris that was left behind, we were left with much of the state left pockmarked with lakes. So when we look to many parts of the state, we find that the landscape is just lakes everywhere, lakes as far as the eye can see. And this is Trout Lake, which is in Vilas County, Wisconsin. And within about an hour's drive from Trout Lake, there are several thousand lakes. So, and each one of these lakes very distinct in its characteristics. So this is really the hallmark of much of the landscape of Wisconsin. And here in this state, we're blessed with about 15,000 lakes, which is more than Minnesota has. So this landscape has a remarkable impact on the culture and the people as well. I grew up in a small town in northeastern Wisconsin, in Neenah, which is in the Fox Valley. And I grew up fishing. So here's a picture of me with a walleye that is probably not legally sized. It's probably below the legal catch limit. Here's me and my little brother vacationing up in Door County. You might even recognize the Horseshoe Island right there. And again, here's me with some large catfish that I caught and my dad. This was a formative experience for me growing up. Fishing on Lake Winnebago is really what I did as a kid. And I also was really nice to my little brother. Notice that? And I passed along that connection to water to my children. I have 2 kids, and we spend our weekends and our free time going to the Wisconsin River, going out on the Madison Lakes. And it is fundamentally a part of the culture here in Wisconsin. And so it's the landscape, and that integrates into the culture and the way of life that we have here in Wisconsin. So for many people, lakes are the heart and soul of our lifestyle here, and it's also the heart and soul of UW-Madison. And the best indicator of that is to look at the UW-Madison website. They have that front page when you go there. And many of the photos that are used that pop up on the front page of the UW-Madison website feature the lakes. Opportunity awaits, forward, centered on the edge, lakes and infinite possibilities. So this is really highlighting the lakes as an amazing amenity to draw people to UW-Madison. This is something that came into my Twitter feed when UW-Madison was ranked number 25 in the world in terms of universities in a recent ranking. Notice the campus perched upon this beautiful lake with sailboats and a gorgeous city in the background. So this is the vision that we want to have for the university and the connection to the lakes. But unfortunately, the reality in our lakes with regard to water quality is often different. And these are just a handful of photos that I took out my window at the Center for Limnology over the past couple of years. So here we have some people out sunbathing on the dock, and there's this awful, horrible cyanobacterial bloom. Here is some cyanobacteria that are being washed down the Yahara River from Lake Mendota into Lake Monona, the bridge that's right near my house on the east side of Madison. Here's just a scoop of water that was taken from the dock at the Center for Limnology. Again, blue-green algae blooms with a sort of a white foamy feature to them. This is from about a month ago. We had a blue-green algae bloom and we got all of this foam accumulating at the surface. So blue-green algae are a symptom of cultural eutrophication, and they occur in lakes because there's too many nutrients being washed in from the surrounding watershed. This is something that is, in my view, not acceptable. We live in a place where we have this gorgeous lake, and we're letting it degrade to these levels. And this is something that people at Limnology have been dealing with for a long time, and we still haven't solved the problem. So to me, this is not acceptable. It is a solvable problem, and it hasn't been solved yet. So we have these horrible nuisance algal blooms, which, by the way, produce toxins, which can be very harmful to people as well. So another reason not to want them, aside from the nuisance conditions that they create. And if we step back and look at the state of Wisconsin broadly, we have a wide range of environmental issues that are emerging. One good example are invasive species, something that I spend a lot of my time studying. Here are the invasive Asian carp that are moving northward through the Mississippi River Basin and causing horrible conditions. When you ride your boat past them, they often will jump out of the air, and you can see that there are just like literally hundreds or thousands of them in this riverway. People who live in parts of northeastern Wisconsin turn on the tap, and their wells are contaminated with manure from the nearby dairies. And so they turn on their tap water, and this is what they get. We have had issues with lakes disappearing, and that has been linked to groundwater extraction in some parts of central Wisconsin. We have nuisance algal blooms and cyanobacteria that can produce toxins. We have issues of declining fisheries, and species like walleye, which are a really important fishery across much of northern Wisconsin and southern Wisconsin as well, have been declining dramatically. Climate change ties into a lot of these, but many of these environmental problems tie into a range of drivers and just the magnitude of the impact that we as humans have on the environment. So we have these multitude of challenges, and so while our geography has given us an abundance of water, and as we sit next to one of the largest reservoirs of surface waters on the planet, we're still facing some major emerging challenges. And the overall view that we at the Center for Limnology take is that as scientists, it's our civic duty to step in and work on these issues and try to work towards finding solutions for these challenges. Now, scientists can't just come in and solve the problem, but we can put our scientific efforts towards doing the research that can lead to solutions, and also to communicate that in a way where that knowledge goes to decision makers who will hopefully act on it. And of course, we can engage in these public discussions and debates as well, and we do. So that sort of embodies what we at the Center for Limnology try to do with our work. Okay, I'm going to transition now after just giving a bit of an overview of water in Wisconsin. Yeah, we have a lot of water, but we also have a lot of issues. And talk a little bit about the history of limnology. The history of limnology is somewhat synonymous with the history of limnology at UW-Madison. It's considered the birthplace of the field of limnology in North America, recognizing that in Switzerland there was a scientist who was making some of the same observations and discoveries a little bit before. So, but there wasn't a lot of communication between these different groups, and so they were really the Wisconsin group was doing their thing on their own. So when we talk about the history of limnology in North America, I like to refer to the first characters in this story as Burge and Judet, and they're really the first generation of Wisconsin limnology. Burge was born in 1851, led a long life. He came to UW-Madison in 1875 after having done his undergraduate degree at Williams College and his PhD at Harvard. His area of interest was the systematics of crustaceans, a group of crustaceans called Daphnia. So this was back in the day when the diversity of life hadn't been very well described, and so he was describing and characterizing new species and trying to figure out how closely related they were to each other. So it was in the realm of aquatic biology in that he was studying organisms that live in the aquatic environment, but it was by no means limnology. He was really focusing on those critters rather than the systems, the ecosystems. As Dr. Merritt mentioned, Burge had a lot on his plate. So I had to write this down because I wasn't going to remember all this. But when he came to UW-Madison in 1875, UW-Madison had about 400 or 500 students. And Burge was a one-man biology department. He taught zoology, botany, bacteriology, anatomy, and physiology. And he didn't really have much of a research program because he single-handedly was teaching primarily students who were being trained for medicine. And so he really put a tremendous amount of effort into teaching in those early years, and he was very well known as a very patient and dynamic teacher, as Dr. Merritt had mentioned. He rose up quite quickly in UW-Madison as well, and again, in these, before long he had become chair of the zoology department, the dean of the College of Letters and Science. He was the commissioner of fisheries for the state of Wisconsin, the director of the Wisconsin Geological and Natural History Survey, and president of the university. Not all of them at the same time, but most of them, right? So he's doing all these things simultaneously, and I do sometimes just think about Burge when I feel like I'm busy, and it makes me feel not quite so bad. So he was juggling a tremendous amount of administrative responsibilities. And mind you, Wisconsin had fewer people. It was a smaller university, but he was a very energetic leader and administrator. The birth of limnology. All right, here we have someone who's primarily an administrator and is running all of these programs at UW-Madison. He had interest in these tiny crustaceans that I had mentioned earlier called Daphnia. And in the 1890s, he had some students that he wanted to get going studying the day-night migration of these crustaceans. So the idea being that they would move through the water column from day to night. They would go down to avoid fish predators because these are really good food for fish. And then during the night, they would come up to feed. There was a study published in Europe that had found that this was happening in Lake Balaton in Hungary, and so Burge wanted to figure out whether this was happening in Lake Mendota. So we sent these students out doing these surveys looking at the amount of plankton at different depths in the water column. And what he ended up describing was the seasonal changes in temperature in lakes. It was really not what he was going after. They found that these plankton did not undergo these day-night migrations. They just kind of sat there. So they published it. But what they did describe in doing all of the sampling out on Lake Mendota, and Burge, by the way, found a sampling site right out in the middle of University Bay, about halfway between the tip of Picnic Point and the Center for Limnology, which is here. So they did all the sampling in one point. And what they found was that in summer, lakes exhibit this two-layered temperature regime with warm water on top and then colder water on the bottom. And then as we move into fall, the surface waters cool, and when the surface water and the bottom water are all the same temperature, the whole water column can mix. And then the lake freezes over and things get kind of boring. In spring, the whole water column mixes, and then it moves into this two-layered pattern again. Now this sort of descriptive depiction of what happens in the temperature in lakes over the seasonal cycle really was the foundation for much of what we do in limnology today, because this seasonal cycle in the temperature regime is the foundation for understanding the chemical and biological aspects of lake ecosystems. And Burge saw that, wow, when the lake is in this two-layered state, there's really nothing happening below. It's devoid of life. Everything is up in the surface layer. And then when the lake mixes, everything gets churned and life is distributed through the water column. And so this was really the foundation for the things that we talk about in the limnology class here at UW-Madison. And 1894 through 97 was that sort of period when these ideas really started to come together. Chauncey Judet is the second limnologist in this combo. Judet wasn't around when this study was done, but Judet was hired on by Burge in around 1905. He was hired on through the Wisconsin Natural History and Geological Survey, but then later shifted over to the university. They were lifelong collaborators, and once Judet came to UW-Madison, these two became a pretty prolific research combo. Burge was primarily doing administration, but he was involved in the research, but Judet was the one who was really out there making it all happen. So they had a lifelong collaboration, and Judet taught the first limnology course in the United States starting in 1909. So Dr. Merritt said that we have the largest limnology course in the world. We also have the first limnology course in the US, so we have a lot of firsts here. I want to talk a little bit about the limnology course. I know most of what I'll talk about is research, but I mean, the teaching classes is absolutely fundamental to what we do as well. And here's the history of this class. This class is called, right now, it's changed over time, but it's called Limnology, Conservation of Aquatic Resources. It was taught from 1909 to 1940 by Judet, then taught from 1941 to 1977 by Hasler, who I'll talk about, 68 to 2000 by Magnuson, and then in the last 20 years it's been taught by the current faculty at the Center for Limnology. John Magnuson, who is the director emeritus at the Center for Limnology, and a student have been doing an analysis of the history of the limnology class, which is absolutely fascinating. If you go back to 1909, there were very few students taking the limnology class, just a handful. And even though Judet was viewed as a reasonable teacher, it didn't get too high of an enrollment. There was a big boom after World War II, and enrollment spiked up to 75 or 80 students, dropped back down again. But with the birth of the environmental movement in the 1960s, we saw enrollment in the class spike. It fell down again in the 70s as people maybe were listening to bad disco music, and then it increased again in the 80s and 90s within this era of environmental awareness. So it's interesting, the color coding is males versus females, and you can see that in these early years enrollment in the class was dominated by men. It's really in the 80s and 90s that we see the woman enrollment in the class shooting up, and now the class is at least 50% female dominated. So big shifts. It's very interesting to think of this class as sort of a microcosm for students' interests in the world and their perception of the world, and fun to see how the enrollment of the class has gone up and down in response to things like wars and renaming of the class and different instructors and so on. So sort of a fun analysis. Okay, so the question is, what were the major features of this first generation, the Burge and Judet era? Well, first off, these two pioneered new instrumentation and measurements. At that time, there wasn't a field of limnology, and they didn't have the ability to measure things because no one had measured them before. So they invented new measurements and new techniques, primarily through collaborations. They had collaborators in the physics department, in chemistry, engineering. They had these fabricator and engineering types who would build them machines to measure things in lakes. And I think the reason why they were able to do this was because Burge was an incredibly powerful person on campus. He was the president of the university, so he could, call on colleagues in other departments and say, "Hey, we need someone that can measure different wavelengths of light underwater. Let's have it." So I think he leaned on colleagues across campus and got them to design these machines for So while they weren't the engineers, they collaborated broadly with other people. And in doing so, they made early measurements of many key limnological variables. Other groups came along and refined those measurements, but measuring the amount of phosphorus in water, measuring the amount of dissolved carbon in water, nitrogen, things like that, these were things that people just simply weren't doing back much before this era. The second thing they did was they interweaved physical, chemical, and biological elements to reveal an integrated understanding of how lake ecosystems function. And I view that as the essence of limnology. Limnology is not just about the biology of organisms, but the physics creates this template. The physics governs much of the chemistry, and the physics and chemistry provide the stage for which these biological interactions play out. And Burge and Judet were really the first in North America to gain insights into the interplay of those. And so when we teach the limnology class now, we're constantly going on about the interweaving of physics, chemistry, and biology. And that those original insights came from Burge and Judet. The third thing they did was they collected vast amounts of data. They would send their students out to collect and generate numbers. And they thought that if enough data are gathered, the data will speak for themselves. They were empiricists. They believed in sampling a lot of lakes. So they would send their students out on these sampling forays where they would go to a different lake every day and collect a long list of measurements. They did their early work in southern Wisconsin, and they sampled about 150 lakes in southern Wisconsin. And in 1925, they established a research camp in Vilas County on Trout Lake, and they called this place Trout Lake Station. And what it was some little shacks, and these shacks were a basis for these crews of students to go out and collect these samples and the vast amounts of data that we talked about. So here are some photos of field crews. These photos at field stations are something that are done everywhere, and they've been done as long as I think there were field stations. So it's really fun to see these photos of these field crews from the different field seasons. They sampled more than 500 lakes in northern Wisconsin over this time period. So they were just hauling their boats around from one lake to another, and then the students would take their samples back to the lab and do their various measurements and processing. So just to summarize the Burge and Judet era, this is the birthplace of limnology in North America, and the field really emerged. The fundamental ideas came out of Lake Mendota in the late 1890s. They're responsible for new measurements and new instrumentation, primarily through working with people who were engineers and physicists. And they established limnology as a multidisciplinary science that draws together a variety of disciplines. They collected a lot of data and established Trout Lake Station. There's a few other things. They didn't really train very many graduate students. Burge didn't train any graduate students. Judet trained 13. And Judet's graduate students were not really working under Judet. They were mostly off doing their own thing independently. I think Judet would maybe sign the papers and say, go figure out your own business. The other thing is that the field crews, these packs of students that were up at Trout Lake Station in later interviews about their experience working for Burge and Judet, said that they didn't really understand the broader plan or context for their day-to-day work. They were told, go out, collect these samples, go make these measurements on 100 lakes this summer, and they did it, and they didn't really see the bigger picture. So I'm not sure they got that great of a training, although some of them did go on to become prominent limnologists in the field. The question is, what was the tie-in to the Wisconsin idea? And I would say that the way I think about the Wisconsin idea of taking the science and translating it to sort of societal well-being, they weren't really hitting the mark in terms of the Wisconsin idea. And I have a little story here that sort of relates to that. Bob LaFollette and Burge were bitter enemies. And this was based on differences in ideas about how the university should be operated. Burge felt that we should keep university activities within the bounds of the campus, while LaFollette wanted the university to spread out and reach the far corners of the state and to infiltrate the lives of the people. So Burge and La Follette had this huge falling out, and the consequence of this was that La Follette had the funding cut for Burge's Natural History Survey. And so there were some rivalries going on here, and that's part of the reason why I think that maybe Burge and Judet were not really working in the full spirit of the Wisconsin idea, at least the way I conceptualize it. Alas, there was another era and another generation, and you can describe the second generation really as the era of Arthur Hasler. He was born in 1908, passed away in 2001. He was Judet's PhD student, but had virtually no intellectual similarities with the work that Judet had been doing. So he did his PhD here at UW-Madison, moved around a little bit, came back as an instructor at UW-Madison in 1937, and there was no connection to Burge and Judet. He was hired by the zoology departments, and there was really no connection to Burge and Judet at the time. He took the program in new research directions, and he truly was a dominant player in the field of limnology over the course of the 1930s through the 70s. He trained 53 PhD students, which is really remarkable, and 41 master's students over that time period. What was the hallmark of the Arthur Hasler era? Well, first off, he was a pioneer of whole lake experiments. He had this vision that, doing small-scale experiments in the lab, which is what a lot of people were doing, really wasn't going to provide insights into real ecosystems. And he understood that many environmental problems were too complex to be studied in a laboratory setting. So why not harness the inferential power of experiments, because we know that experiments are a powerful way to make inferences about how the world works, but to do it out in real natural ecosystems. So he essentially came up with the idea of conducting whole ecosystem experiments. And this is where he conducted his first whole ecosystem experiment, which is a lake that was hourglass shaped. And that makes a perfect experimental unit because what they did was the lake had these two basins, and they created a barrier with a culvert between the two. And so now what you have are two lakes that are really one lake, and you can do a manipulation on one side and use the other half as the control, or as he called it, the reference basin. And he was able to do several experiments in these types of hourglass-shaped lakes, conduct experiments, and come up with very strong evidence for the hypotheses they were testing. So these whole lake experiments were pioneered by Arthur Hasler, and they continue at UW-Madison in these very lakes until the present. There is an NSF-funded research program that's led by Steve Carpenter and his colleagues that has been ongoing on these and adjacent lakes since 1982. So they have had about 40 years of consistent National Science Foundation funding to conduct lake experiments. And this work started by Hasler and carried forward has produced many seminal insights into how ecosystems work. So that was one big contribution of Art Hasler. The second was studies of fish ecology, physiology, and behavior. Now, limnology generally does not branch out into the area of fish. Art Hasler was someone who felt that fish are part of aquatic ecosystems and we need to incorporate them into our understanding of them. That was very cutting edge, and it still is even today. If you go pick up a limnology textbook and page through it, there's virtually nothing about fish in it. Art Hasler did a lot of work on fish and their role in ecosystems. At the time, one big question that was on people's mind is how salmon navigate to their home stream to spawn. Salmon reproduce up in the Pacific Northwest in particular, reproduce up in headwater streams. As the juveniles will spend their early life in these streams, they'll go out to the ocean, and then somehow they navigate back to those home streams. And it was not known how they do that. Well, Art Hasler took a trip as an adult back to his childhood home in Utah, and he had this experience whereby the smell of his surroundings brought back childhood memories. And that inspired him to think that perhaps the way that salmon make it back to their natal streams to spawn is through sense of smell. And he then laid out a series of very testable hypotheses using the scientific method, and then went about testing these hypotheses over the course of his career. And they conducted a series of very elegant experiments demonstrating that it's the sense of smell that allows a fish to go back to their natal streams. And so this process is called olfactory imprinting. The juvenile there's an imprinting of that smell of their natal stream. All streams smell different because of differences in the soil and vegetation and geology. And that imprinting allows them many years later to make it back to their home stream. So this is basically something that was demonstrated by Art Hasler and his students. And it's actually kind of a weird thing for a limnologist to be studying. I mean, this is fish physiology. Third hallmark of his career was the study of cultural eutrophication. And this is essentially the degradation of freshwater ecosystems as a consequence of excessive nutrient inputs to lakes. This was a huge issue in the Madison lakes, primarily because there was sewage from Madison going right into the Madison lakes, not Mendota, but Monona and lakes downstream. And the upstream communities had sewage that was going right into Lake Mendota. In addition, there was farm runoff coming from these lakes and poor agricultural practices. So he got into the fray of studying cultural eutrophication and got involved in the issues of the day pertaining to controlling this pollution, was actively involved in community efforts to address these issues, communicating about what the causes are, conducting science to try to determine what the causes are as well. And so this ties in then to his public service orientation. So he got engaged in public policy and advocated for protection of lakes and streams, often surrounding this issue of cultural eutrophication and the need to manage our nutrients better. He had this view that people just need to understand how lakes work. And a thing that I've heard many of my colleagues say is that he thought that every drugstore clerk in Wisconsin should know the basics of limnology. So there's this idea that we need an informed populace in order to be informed voters, and that was just part of his role as a limnologist, was to try to get people to understand how lakes work, just the basics. Notably, he changed the name of the limnology course to Limnology, Conservation of Aquatic Resources in the 1940s, which I find remarkable because in the 1940s, people just really weren't thinking about conservation. But he, for some reason, felt that this was what he wanted the class to be named. So he was not a pure basic biologist. He wanted to see these applications of the science to addressing real-world problems. He also overlapped with Aldo Leopold at UW-Madison for about 10 years. And I know there were connections between the two, and so perhaps some of the conservation ethic from Leopold rubbed off on Art Hasler. Another thing about Art Hasler, the fifth, was that he was a program builder. He established the Laboratory of Limnology in 1963. So this building here is now called the Hasler Laboratory of Limnology. It was built in 1963, and notably around that time, there were proposals to build a massive parking lot out in Lake Mendota. It was a big debate in the late 50s. The proposals were being debated by city council and so on. And also discussion of having a major throughway where the Lakeshore Path is. Art Hasler raised the money to put this building right here at that narrow spot, blocking any future development. And this building is basically the reason why we have this beautiful Lakeshore Path. So, So thank you, Art Hasler. At the time, apparently, having a big highway right along the lake seemed like a great idea, so, to some people. So that was 1963. The building went in. He reestablished Trout Lake Station in the mid-1960s, and he raised the money to put in a nice building at a different site, but still on Trout Lake. So you can see there's some continuity between Burge and Judet, who were also based at Trout Lake. he had this station built at a different site, but they took the buildings, the dilapidated old buildings from the Birds and Judet station and dragged them across the lake to the new site. And, but they also built this larger structure, hired staff, and Trout Lake Station took off as a field station. They built a world-class limnology faculty. John Magnuson, Jim Kitchell, and Steve Carpenter were the three dominant limnologists at UW-Madison from the 60s through really through 2017 when Steve Carpenter retired. So these three characters really dominated the field over this period. And so what we saw then was this program solidifying. There were multiple faculty in place. This group of new researchers brought in new ideas. Diverse approaches to studying inland waters were brought in. A lot of the fundamental ideas that Art Hasler had were built upon. The range of research questions broadened. Collaborations continued across campus. And the researchers, the faculty that came in, carried on the tradition of conducting research in the service of the public good. And so these are some of the themes that have been dominant at the Center for Limnology starting around this era and continue until the present. In 1980, the Center for Limnology secured a coveted NSF-funded long-term ecological research site. There's 28 of these in the US, and these sites provide long-term funding to address ecological questions that you just can't answer in a 3-year funding cycle. And so we've had this funding to study lakes in the Madison area and up at Trout Lake dating back to 1980. And so we have a 40-year data record funded through the National Science Foundation, and this was spearheaded by John Magnuson. Another study that really embodies the Wisconsin idea was the food web biomanipulation study in Lake Mendota that was carried out in the late 1980s. So the lakes had poor water quality, seems to be a recurring theme, and researchers at the Center for Limnology, Carpenter, Kitchell, and Magnuson, partnered with the Wisconsin DNR, and they had a crazy idea. And that was that if they stocked tremendous numbers of walleye, which are top predator fish in the ecosystem, into the lake, they would alter the food web in such a way where they would increase the abundance of this animal here called Daphnia. And Daphnia are really good at feeding on algae. They're a grazer, and they're capable of cropping algal populations and keeping algal blooms at bay. And the idea being then that if we increase the amount of Daphnia, we'd get clearer water. And so they actually did this. They had millions of walleye stocked into Lake Mendota. They transformed the food web. Daphnia did remarkably well, and the lakes cleared up. Now, the lakes were not perfectly pristine lakes from during the 1990s and the 2000s, but the water quality was relatively good considering how much phosphorus was coming in. In the year 2009, an invasive species, the spiny waterflea, came in and completely screwed all of this up. But because of this experiment, we had about 20 years of very good water quality given the amount of nutrients that were coming in. So this is another example of combining scientific ideas and letting them play out in the real world to test hypotheses about how we might be able to improve environmental quality. The Center for Limnology today, we have 4 faculty members, and we have our academic homes in the Department of Integrative Biology. We have 4 research scientists, some down in Madison, some up at Trout Lake Station, and then we have our emeritus who are all still active and are valuable members of our community. We have lots of grant-funded staff, lots of graduate students, postdocs, and typically in a given year we'll have at least 40 undergraduates carrying out independent research studies in our program. So we have lots of undergraduates that get involved in the research, and hopefully they know why they're doing what they're doing, unlike the Birds and Judet era. Well, you'll have to ask them. I went to the Center for Limnology website, and I found our mission. And I didn't just change this when Dr. Merritt asked me to give this talk. But the mission of the Center for Limnology is to exemplify the Wisconsin idea by providing new knowledge and information on aquatic ecosystems through research, education, outreach, and public service. And then there's the second one, which I'll get to. So I just want to talk a little bit about how we do that. The foundation of what we do is conducting research on lakes and inland waters, and that's really the core of what we do. But the way we do that is by training the next generation of water scientists. So almost all of our research is carried out by graduate students and postdocs, and as I mentioned, undergraduates. So they're very involved in the research endeavor. And so that training and the research really click into each other. And we find that students learn so much by having these hands-on learning experiences. So we can't really even tease apart our research and our training. And then, of course, we view ourselves as a trusted source of information about inland waters and their management to diverse audiences. So we want to take the research we do and bring it out to the general public and to managers and policymakers. And so we view integrating these three as our way to the Wisconsin idea, and our goal is to bring our research to bear on societal and public policy issues related to fresh water. And so I think this is where, for us, the Wisconsin idea hopefully kind of comes through. We try to think of our research as getting out of the ivory tower. Yes, we're a university, we're part of the ivory tower, but here's some examples of how we try to extend beyond that. We've done a lot of work on aquatic invasive species around the state of Wisconsin. We have taken that knowledge and we've synthesized it on a website that is basically a web tool that allows a user to choose the species they're interested in, and then they can zoom into different parts of the state of Wisconsin and see whether and which lakes are vulnerable to future invasions. So you may be living on a lake and saying, do we need to worry about a zebra mussel invasion? Well, it ends up being that your lake doesn't have enough calcium, zebra mussel won't live there. So this tool allows people to go in and assess that. So there's a bunch of different species on the tool, and you can zoom into all parts of the state. So resource managers, the DNR, the counties, lake associations use this tool to assess how they should be thinking about invasive species risk. Another example, our newest professor, Hilary Dugan, had been doing research on salt in lakes. We put salt on roads to get rid of the ice, and that salt often washes into lakes, and we've been seeing a signal of this in the chloride concentrations in lakes over time. So there's been a steady uptick in chloride concentrations, and get a little bit above where we are now, and chloride ends up being toxic to many aquatic organisms. So we've documented this upswing in chloride concentrations in our lakes. Hilary Dugan has been going out giving talks to the Department of Transportation and the county roads departments, trying to get them to understand the magnitude of this and then to change the way they apply salt. And it ends up being you can apply salt in much more environmental friendly ways. What they do is they take the salt and they create a brine, and they can put a very thin layer on the roads, and it uses much less salt. It actually saves them money, and it has much less stress on our lakes and waterways. So, here's the research, but then bringing it out to the community and having it hit the ground with the Department of Transportation. And she's been really successful with that. And finally, we have these issues of harmful algal blooms, which are a recurring problem. And we have done a lot of work at the Center for Limnology on the drivers and causes of harmful algal blooms. And we work very closely with the Clean Lakes Alliance. Right now, we're in the process of going through what's called Yahara Clean Compact 3.0, where various stakeholders and researchers are trying to figure out what we need to do in order to solve these horrible water quality problems in our lakes. And the science done at the Center for Limnology and other people at the university as well provides a foundation for the recommendations that the Yahara Clean Compact will do. And notably, UW-Madison is a top-level signatory in this agreement, and it was really heartening to see UW-Madison as an institution buying into this process and engaging with these other partners. We do a lot of other specific things that get us out of the ivory tower. I'll just give you a few examples. We run something called Science on Tap. It's a monthly science pub. And this is Dan Egan. We had a Science on Tap with him when he was here for the Go Big Read book, Death and Life of the Great Lakes. There's a Science on Tap tomorrow night. and we're a co-host of that. It's at the Winnebago, and it's on PFAS, which is an emerging contaminant that has been in the news. It's a serious concern, and it's something that researchers are just starting to wrap their minds around. But that's tomorrow night at the Winnebago. We also have a Science on Tap in Minocqua, which is the nearest city to Trout Lake Station. And again, this is a monthly event where we have speakers coming and speaking in a science pub. At Trout Lake Station, we have an artist in residence program. The idea here is to foster interactions between our scientists at Trout Lake and artists, mostly from that area. And it has been really fascinating to see the cross-pollination between these two disciplines, and I think arts and science both have a lot to give each other. So we bring these artists to work on station during the summer. This last summer we had 4 artists on station who were going around with the scientists and having conversations and doing their work from on-site. So the project is called Drawing Water, and every year we bring in artists to the station. We do tons of open house events as a way of public outreach. We think that is fantastic just to get people out on the lakes to learn about them. So here's an open house in Madison. We have open house events up at Trout Lake Station. We love getting people out on boats because that is just a fantastic way to learn about our aquatic ecosystems. And then finally, we put a lot of effort into communicating our work to non-scientific audiences. For us as a unit, the turning point was 2011, and we hired Adam Hinterthur, who is a journalist, to come into the Center for Limnology as an employee. And the idea was that he was going to take our work and put it out there to the world. At first, he wrote a lot of press releases. But a few years in, we thought, well, why don't we just serve as a direct information source to the public? And we launched a blog, and our blog has become quite popular. And so now a lot of people turn to our blog as a source of information about what's going on out in the lake. So if there's a big algal bloom out on Lake Mendota, we'll probably have a blog post written by Adam on what are the causes, what's going on out there. And of course, he has a lot of other content aside from just the algal blooms on Lake Mendota. So we have a large social media presence. And we've decided that we can take this into our own hands and take our knowledge of lake ecosystems and just put it out there on our own without having to go through the press. I suppose that's the way that modern communication goes. People are going to get their information about how the world works from somewhere, so it may as well be us if we can have it be that way. So I mentioned as our mission there were 2 parts. The other is to facilitate and support research and teaching around our facilities at Trout Lake and in Madison. So Virgin Jude had Trout Lake Station. Hasler sort of revamped Trout Lake Station in the 1960s. Trout Lake Station today is a very active place. Essentially, it's a little mini UW-Madison campus located up in Vilas County. And a lot of people up there don't know that this is here. So here's the station now. The original building that Hasler built was this section right here. We've added on to it a few times, and we have a number of other buildings that go along with it as well. In 2018, we had 13,000 user days at the station. And again, if you look at this map of the 4-year campuses of the UW system, this whole area of northeastern Wisconsin, northern Wisconsin, is not very well served by the UW system. So we are up there, and we're a little beacon of UW and UW-Madison in the Northwoods. The facility has lots of boats and all of the limnology sampling gear you would need, so you can go up there and grab the nets that you need and so on. There are microscope rooms, various lab facilities, and conference facilities as well. There's housing for 48, so we can accommodate a lot of students up there. And in the summer, the station is filled with undergraduate students and graduate students conducting research projects, and it's very much of a buzzing place. And many of these cabins, these residence cabins, are full. It is a place where literally thousands of undergraduate students have had hopefully transformative experiences doing hands-on learning. It's not just students from UW-Madison, but students from other UW campuses and beyond. use this facility as well. And we often host researchers from universities all around the country who want to work on lakes in the region. And these photos just sort of embody the types of things that are going on up there. But many undergraduates and graduate students have had a hopefully transformative experience basing their studies out of Trout Lake. And I also want to mention the Hasler Lab facility. Our role with this Hasler Lab is also to provide access to the Madison lakes. So if someone is teaching a class in aquatic chemistry and they need to get their students out, we provide them boat access so they can go out and do their lab. And of course, there are researchers from all around campus that want to do work on the lakes, and we give them boat access and sometimes equipment access to do what they need to do. So we have around 400 boat trips per year. We have a couple of smaller whalers that are used for day-to-day research. We had this boat here called the Limnos, which was acquired by Art Hasler in 1967. And 2019 was his last year. It really didn't work anymore. And we had a lot of mechanical problems, and we had to cancel a lot of field trips for classes and so on because of mechanical issues. And in 2019, with help of the College of Letters and Sciences, we purchased what's called the Limnos 2, which is a very practical pontoon boat. Does not have the iconic value of the old Limnos, but it gets us out there. So you can put 17 or 18 students on the Limnos. You can, Limnos 2, go out on the lake and collect data on thermal stratification and zooplankton or whatever you want. So we really put a lot of effort into making sure that people who want to get out on the lake for research or teaching or outreach can do so. So I think my hour is up. I'll make some final reflections. Maybe historians know this, but I, in putting this together, was just shocked by the extent to which the present is so much a function of the past, but not in a very linear way, right? So, I mean, Bertrand Judet worked on Trout Lake, and then when Art Hasler decided he might want to go do work up north, even though he didn't have a connection with Bertrand Judet, he went to Trout Lake and started up his field station on Trout Lake. And so I think if it weren't for Bertrand Judet, Hasler wouldn't have located the program on Trout Lake. So there's really, I think, where we are as a program today is deeply, deeply connected to the things and the decisions that people made along the way, which maybe that's obvious, but I really was struck by that as I was putting this together. Second is that Bertrand Judet could not be described as proponents of the Wisconsin idea as most people would envision it. And there was a huge discontinuity between the Bertrand Judet and the Hasler era, yet they still were in many ways connected. I mean, Hasler was a Judet student after all. Fundamentally, the core ideology of the CFL today, conducting basic research but also making that research work for public policy and public well-being and bringing that knowledge out to the broader public, this emerged in the Hasler era, and it fundamentally hasn't changed. Of course, we do different things. We're concerned about climate change and invasive species. These were things that were not even on the radar in the Hasler era. So the scope of the work has expanded. We have many new tools that they didn't have in the Hasler era. For example, we put sensors out on lakes, and we get continuous data streams coming off of systems, so we don't have to go sample as much. The topics have evolved, but the fundamental ideology stems from the Hasler era and has continued on to the present. So that's it for my talk. Some information about the Center for Limnology and me here, and I'm guessing we have time for questions, right? Yeah.
Well, we will take questions, comments. The kinds of wrap-up just now is very relevant for what we'll be doing in this entire course. There's been this issue of thinking about the Wisconsin idea and what are the consequences and the discontinuities. Change occurs, and this then says that that's what we have to pay a lot of attention to. So I think that there are lessons from all of this that carry through for what we'll be probing for the entire semester. But as I've said another time, I'm not here to talk. So let's see where the questions and comments might be. Yes. Okay.
I'm wondering, if you had 5 years of magical powers and you could have as much money as you wanted and could be as tyrannical as you wanted, could you clean up the mess in lakes, and how would you do it?
Wow.
You got the money we're planning to give it.
It's a very vexing issue. On the science side, we know what we need to do, and that is to reduce the amount of phosphorus coming in. The problem is that we have an uphill battle because over the past decade, we've been seeing more of these large rain events that bring in huge amounts of phosphorus. And so as farms have been implementing these best management practices and better land use, those improvements are being overwhelmed by these large storm events. So we need to reduce phosphorus, and if we had enough money, we could probably convert these land uses to land uses. But it's going to involve changing the way we farm in the watershed, is the answer. And that's really not my area of expertise, and I know that it's easier said than done, and I'm not a farmer, so yeah.
I think, yeah, okay.
Could you share your perspective on the impact of the rising water levels and the health of our lakes?
Yeah, that's a very good question. That stems from what I had just mentioned. We're in a regime where precipitation is incredibly high, and we've been having these large storm events even over the last 24 hours. We've had them, and we're seeing really high water levels. It's an issue that dates back to the early years in Madison when they brought up the water level in Lake Mendota. At this point, we have these higher levels now, and so is it possible to sort of adapt the way our infrastructure is set up to be able to protect, people who live around the lakes and not have to deal with these flooding issues? So sort of to answer your question, I probably need to bring the water levels down in Mendota to provide a little more capacity. Need to increase the rate at which water moves through the system through some engineering type projects. And, the future is not going to be the way it has been in the past. And we're really seeing this now with this increase in these large precipitation events.
Does it actually affect the health of the lake, though? If you can't move the water, does it still affect the health of our lakes being just more water?
The health of our lakes, if I could identify the key driver there, it doesn't have anything to do with water levels. It has to do with too much phosphorus coming in. Now, there can be some issues. For example, with these high lake levels, we have some erosion around the edges. And like the park near my house, you can see like the soil is basically just being eaten away. In the grand scheme of things, that's probably a minor source of phosphorus compared to the phosphorus coming off of the agricultural landscapes. So, it's an issue, but I would say it's probably minor compared to the phosphorus issue. I think of the phosphorus as the elephant in the room. So.
Yes,
Recently, there's been a statewide initiative that I think is involving all of the UW system campuses to address freshwater. Can you talk a little bit about that and what UW-Madison's role might be in it?
Sure. Yeah, this initiative is called the Freshwater Initiative of Wisconsin. And the idea is that all of the individual UW campuses have strengths in water. And so why don't we band together and attempt to build a cross-campus program where students can take classes across the campus. And so each campus, across the campuses, so each campus would have its own program, but they're connected to the other campuses' programs. It would be an influx of resources because in order for us to offer a freshwater sciences major, we'd probably need to boost up some of our course offerings, and it would be something that would really float the boats of the water programs in all of the four-year campuses. So UW-Milwaukee spearheaded the thing, but UW-Madison and all the other campuses have been involved in it. So I'm obviously supportive of it. I think it's a great thing. So it's in the discussion phases, and a little bit of money has been released, but it hasn't come to fruition yet. So we'll see.
Well, actually, he's an important person.
Yeah. Oh, yeah. Okay.
Raise a question like this, Professor Sandgren. with the university committee, thinking of the other question that was raised, where you were talking about the imperative, the importance of working across very different fields.
Yeah.
So at the time when this campus was a smaller one, when there could be that interaction between the people in engineering, in agriculture, in letters and science, and the arts, but of course that's within letters and science. So I think his question has really been, what might we do to try to foster the kinds of interplay to address many of the sorts of issues that you're talking about, that are arising at this time. And that's what I believe a lot of people are interested in having something that brings things together in important ways that we might not be focusing as much on now as they really deserve to be. But again, I think there were some other questions or comments from...
And if there isn't, I do have an answer to that.
Okay.
In the last 5 years, a group of the water researchers on campus banded together and created something called Water at UW-Madison, which is a grassroots group of people from all different disciplines. And it's nothing fancy, but we have a website, we have events that we throw, poster sessions, symposia, and the idea is to bring together the water people into a common purpose, to foster collaborations, to provide some identity amongst all of the water people on campus. And what we found out was that there are way more people doing water here at UW-Madison than we knew. And so if you go to the UW-Madison website and you look at the affiliates, I think we're somewhere around 120 faculty and permanent research scientists at UW-Madison who have scholarly work that ties to water in some way or another. So all of us at Limnology are on there, but there are two people from the dance department, for example, number of people from the art department, and on and on and on. And so it's meant to span the disciplines. It's not just for water scientists, but it has provided a mechanism to really bring together people with this common interest of water. And the people involved in water at UW-Madison have interest in many different dimensions of water. And so that has been a positive thing here at UW-Madison, has brought people together. Yeah.
Is anyone doing similar research to what you're doing with respect to the Great Lakes? And is anyone doing work similar to what you're doing in other countries?
Yes, I think so. There are research programs on the Great Lakes at universities all around the US and Canada. A lot of the Great Lakes research funding goes to federal agencies. NOAA and the USGS carry out a lot of that research, but certainly most universities around the Great Lakes region have projects in the Great Lakes, including here at UW-Madison. There's a number of researchers that have work in the Great Lakes. UW-Milwaukee has a large Great Lakes focus, and UW-Green Bay does as well. Internationally, again, Canada is a remarkable place for freshwater research, and many of their universities have large programs and sort of a critical mass of faculty members. I did my PhD in Canada. It has just been a place to go for water, and they have a lot of water, so it makes sense. But anywhere you go, you can find critical nodes of researchers working on some of these topics. We do a lot of work internationally as well at the Center for Limnology, so we've had projects in Mongolia and Iceland and Mexico and on and on. But I mostly talked about our work in Wisconsin. So.
I think we've got time for just one more. I saw a hand back. Oh, yes. Here's the microphone coming.
What is the website for the water people? You mentioned the water people.
It is right here. The water people. Yeah. So this is, if you were looking for an expert on a particular topic, let's say you wanted to find a water economist, maybe if there is one on campus, they're probably going to be listed here, right? Okay. And there's other things on that website as well. So this is really, really broad. Yeah.
All right. Well, I think that was the last question. that we have the time for this formal session, but if you would again join me, and thank you, Professor Vander Zanden, for